As we start to talk about circles, we're going to start talking about inscribed angles, which are going to lead to a couple different terms. Inscribed angles are going to be angles that are, they start and they end on a part of the circle, with the vertex of that angle being on the circle as well. So you can see we have two different sets of inscribed angles. We have my endpoints, which are on the circle. My vertex is on the circle. So I have an inscribed angle here. When I have that inscribed angle, what I create is this arc. This intercepted arc is what we're going to call it. And when we have these angles and these arcs, the arc is always 2 times whatever the angle is. So in this case, if my angle was 30, my arc would be 60 degrees. If my angle was 40, my arc would be 80 degrees. That's how an inscribed angle works. It always has that relationship with the outside arc. So we can look at problems like the one below, and we can solve a couple things. If I know that this arc is 60 degrees, I can find this angle. Remember, the angle is always half the arc. So that angle is going to be 30 degrees. Now, at the same time, if I've got an angle that's 70 degrees, my arc is going to be twice that, or 140 degrees. So it's a pretty simple relationship. You just have to get used to actually seeing it and using it. Over here, I've got a 20-degree angle, which I could say is going to result in a 40-degree arc. And going backwards, if I have a 90-degree arc, I have a 45-degree angle. So it's anything where we have an inscribed angle, it creates that kind of relationship for us, which isn't too difficult to work with. Now, the only thing we have to realize is if I have a central angle, so if this is my central angle here, whatever the measure of this angle is, it's going to be the same as this arc. That's the only thing I have to understand. The difference between a central angle, which means the vertex is at the center, and an inscribed angle, which means my vertex is on that circle. A couple other relationships we have. If I have a tangent and a chord, so I have a tangent line and I have a chord, I create another type of inscribed angle. And I can say that really the same relationship occurs. This value, which is my angle value, is going to be half of whatever the arc is. Or I could say the arc is twice what the angle would be. So if I look here, I have an example down here. If I have the arc AB is 88 degrees, I know that my angle, so my angle ABE is going to be equal to half of that, or 44 degrees. Now over here, I've got a 90-degree arc.
Looks like there's a problem.
So I'm going to have from FGH, I've got a 45-degree angle. And then here, if I have a 75-degree angle, then I know that my arc should be twice that. 2 times 75 is 150. So arc IK is going to be equal to 150. So that's not a terrible situation either. The last thing we're looking at is when we have a pair of vertical angles in a circle. So in this case, I have a pair of vertical angles here. I know that this angle and this angle have got to be equal. And what I'm looking for is this angle here. Now, this relationship is really simple. What I can do then is I can take this intercepted arc, which is 106, and I can take this intercepted arc, which is 174, and I can add those two together, divide them in half, or take the average of them, and that'll tell me both the angle of my x's here. So 106 plus 174 would give me 280. Half of 280 tells me that both of these angles are 140 degrees. Same thing here. If I've got GJ is 110, GJ is 110 degrees, and HK is 98 degrees, and I'm trying to find these two angles here. I know they're going to be equal to 110 plus 98 divided by 2. So I will have 208 divided by 2 will give me 104 for these angles. So I got 104 here and 104 degrees here. So really that's not very difficult relationships here. You just have to be able to decipher between the two and understand what the rule is.